What I'm going to do to study for the test is I'm going to kind of go through the topics, give you maybe a couple of examples. If there's some things I think you should practice, I'll give you one to try on your own. Otherwise, if there's anything that I kind of breeze over that you think you want to see more detail, just let me know and I'll give you some more detailed problems about it. So one of the things we're going to need to be able to do, basically looking at the equivalent fractions or proportions, you might have something like 4/5 and ask how many 45ths is that going to be. There's two different ways you can approach this. You can look at it as equivalent fractions, as I said. 5 times 9 is 45, so you have to do 4 times 9 would give you 36. Or you could handle it just like we did with the problems we were working with using a proportion. You might have 3/8 and ask how many 120ths is that. You could still do 8 times what is 120 and do that, but we could also cross multiply and divide like we just did. 3 times 120 is 360, then divided by 8 is going to give us 45. We're going to have our order of operations. Stuff like 9 plus 3 times 12 minus 7 times 4. So what are we going to do here? What would we do first? So in the parentheses. In the parentheses, what do we have to do first? 7 times 4, which is 28. Still in the parentheses, we would have to do 12 minus 28, which is a negative 16. Now we don't need the parentheses anymore as an enclosing symbol because we're down to a single number. But because that's a negative 16, I'm going to leave the parentheses on it just so that we know that's 3 times negative 16, not 3 minus 16. What would be next? 3 times negative 16 is negative 48. So 9 plus a negative 48. Again, I'm going to leave parentheses on there to show you, highlight that that's a negative 48. And now we have positive 9 and a negative 48 is going to be negative 39. Perfect. Or you might have problems that are set up like this. So here, what would we have to do first? Well, the fraction bar is an enclosing symbol telling us we have to do everything on top first. So on top, what do we need to do first? Careful, that's 2 times 5, not 2.5. I should have been more clear. My dot was a little low, that's my fault. These are times down here as well.
So 2 times 5 is just 10.
2 times 5 is 10. Okay. Perfect. 9 plus 10 is 19, minus 1 is 18. On the bottom, we do have 7 times 9, which is 63. Then we have the 6 times 9, which is 54. So 63 minus 54 is 9. So this is 18 over 9 or 2. Perfect. We might run into solving equations where we'll have something like 3/4 x equals 27. What would we do with something like that? Well, what if we had 5x equals 65? How would we solve that? The x has been multiplied by 5, so to solve it, we're going to divide by 5. X equals 13. Over here, x has been multiplied by 3/4, so we're going to divide by 3/4. You can use the fraction calculator, or you can set this up. 27 over 1 divided by 3/4. How do we divide fractions? 27 over 1 times 4 over 3. Now here we can cross cancel the 27 and 3 to give me 1 and 9. 9 times 4 is 36 over 1 times 1 is 1. So x is 36. I'm going to skip some of the simpler ones and go to examples like what's that going to be? Let's try that. See if that works. So in a problem like this, where are we going to start? Okay, we've got the parentheses. So first we have to make sure there's nothing to do in the parentheses. And here there is not. So now we are going to multiply by the 7. So we're going to distribute. 7 times 3x is 21x. And then 7 times negative 2 is a negative 14. Still equals 133. Then what? Add 14 to both sides, so it takes away the minus 14 here. 21x equals 147. And then divide by 21. X equals 7. And as always, if you wanted to, you could take that back and put 7 in here for x and make sure that that works out to be the same value on each side. Or you can run into questions like this. What would we do here? Okay. Well, let's break this down. We find our equal sign, and we can reduce what's on the left side first, and then reduce if we can on the right side. We actually see here that there's not going to be anything to reduce on the right side, so we're going to concentrate on the left. We see two sets of parentheses, so we're going to go left to right. The first one is right here. Is there anything to do inside that parentheses? No. So, but there is something to do to the parentheses, which is times 10. Distributing the 10, 10 times 2x is 20x. 10 times 8, so it's a positive 80, so plus 80. Now I'm going to go ahead and do this next one as well. This parentheses has nothing to do inside, but it's being multiplied by not 6, but negative 6. Good. So it's negative 6 times 3x is negative 18x. Negative 6 times negative 5, positive 30. Very good. I don't need to put the other side up there yet. Anything else I can reduce or combine on this side? We've got 20x and negative 18x make 2x. 80 and 30 make 110. Now we've reduced everything we can on that left side. On the other side, the 8x minus 4, there really isn't anything to do with that so far. But we do still have a variable. X appears on each side of the equation. So we're going to have to get rid of one of them. Which one? The 2x. We'll usually try to get rid of the smaller one. So we're going to get rid of 2x. We subtract 2x. It is now gone. But we have to remember to do the same thing to the other side. We can only take 2x away from the 8x, which will leave us with 6x. And we still have the minus 4. Now what? Add the 4, because it's a negative 4. So 114 equals 6x, and then divide by 6. Gives us x equals 19. Any questions? Anybody feel uneasy about solving equations, wants to see more examples? Okay. Well, then let's move on. We're going to cover what we just did with percents tonight. I'm converting percents to both fractions and to decimals. And then, of course, back again. So what if I had 7 3/4 and I asked you to convert to a percent? How are we going to do that?
Well, you take that into improper fraction.
Okay, we can turn into an improper fraction. Good call. 7 times 8 is 28, plus 3 is 31. So it's 31 out of 4, but a percent is always out of 100. So now we're going to cross multiply and divide. 31 times 100 divided by 4 is 775. So that is 775%. If I asked you to convert 4.7 to a percent, what's it going to be?
It's going to be 0.
Careful. To a percent. From a decimal to a percent. Remember, decimal's out of 1, a percent is out of 100.
So that's going to be 470.
Perfect, Cody. 470%. What if I asked you to convert 271% to a decimal? Yeah, percent's out of 100, a decimal's out of 1. So we have to make this smaller by dividing by 100. 2 decimal places is 2.71. How about 344% to a fraction? It's out of 100, exactly. So it's 344 out of 100. But we can convert that into a mixed number. How many times does 100 go into 344? 3 times. That would be 300 with 44 left over. And now we can reduce by 4. Very good. So 44 divided by 4 is 11. 100 divided by 4 is 25. And we cannot forget the 3.
Forget 3 is wrong.
Yes, it is. How about this? (36.5% to a fraction. 36.5 over 100 is where we start again, as usual. And then we have to get rid of the decimal.
So you have to times by 10.
Perfect. There's one decimal place, so we're going to multiply by 10. So this is now 365 over 1,000. That can be reduced by, say 5. 5. There we go. So that becomes 73 over 200. That's as far as we can take it. Anybody have any questions on converting the percents? And then we're going to have, just like what we saw earlier, questions like find 65% of 160. So, of course, 65 over 100, because that's a percent. 160 go top or bottom? 160 on the bottom. We're going to cross, multiply, and divide. 65 times 160 divided by 100 is 104. Perfect. Or we might have 63 is 90% of what number? So again, we have the percent. We have the 90%. 90 over 100. Where does the 60 go? Top or bottom? 60 is 90%, so it goes on top. So, sorry, 63, I should say. So we're going to cross, multiply, and divide. 100 times 63 divided by 90 is 70. Or you might have 84 is what percent of 60? Don't know the percent. Perfect. 84 is what percent? So 84 matches up with our missing percent. Perfect. 60 is on bottom. Cross, multiply, and divide. 100 times 84 divided by 60 is 140. So that's 140%. Makes sense. Good. Any questions? Okay. Well, let's say that you win $120,000, but must pay 42% tax. How much do you get to keep? I'm going to have you guys try this one in your notes quick. So how are you going to set this one up? If you look really close, this is actually a percent decrease problem. So we could set it up that way. Or in this case, you could just find the 42%, but you'd have to do a little extra work after that. Anybody have a preference? Just finding the percent or doing the decrease? Find the percent. Okay, so we have 42%. What's going to go on the other side? We have the 120. Where's that going to go? On bottom. Okay. So now if we cross, multiply, and divide, 42% times 120 is going to be what? 50,400. So is that our answer? No. That's the amount of the tax. We need to know how much you keep. So we would have to do the 120,000 minus 50,400. So $69,600 is what you would keep. You could have done it as a decrease as well. Win minus tax equals keep. Again, whatever words you want to put in there. 100% minus 42 means you keep 58 out of 120,000. And you could cross, multiply, and divide. 58% or 58 times 120,000 divided by 100 would have given you the same number. Let's say you receive a 12% discount for savings of $17.28. What was the price for the discount? I won't make you do this one on your own. Just walk me through it. Again, we could do this as a percent decrease. Anytime you see a discount, of course, you're thinking percent decrease, right? So let's do the before the discount minus the discount and after the discount. And of course, 100% is what we started with before the discount. We had a discount of 12%. What else do we know? 1728 goes where? The dollar amount of before or the discount or after? Savings of, so that is the discount itself. And we are looking for the price before the discount, this one here. We could have found this percent here as 88, but we don't need that bottom row, so we didn't need to bother. Cross multiply and divide, 100 times 1728 divided by 12 is $144. Perfect. Oh, let's see, what else do we have? Let's look at, this will be a happy example for you. Statistics show that 35% of students do not finish college. So, out of 600 new students, how many will not finish? We have the 35%. What does that 35% represent? What does the 35 represent? Those who do not finish. So the 100 would represent all students. So in this case, on the other side, we're looking for the number that don't finish. So we're looking for this number here. The 600 goes on bottom. So we would solve 35 times 600 divided by 100 is 210 that we would expect not to finish. Hopefully our number's a little better than that. Let's see, going back a week or two here, let's say that day shift produces go 5 times as many units as night shift. On a day where 1,780 units are produced, how many are produced by each shift? So last week we talked about this when we were doing the algebra and solving equations. The tough part is setting up the equation. So we have day shift and night shift. And we're looking at the number of units produced. We have to find some way to represent the number of units from day shift and night shift using the same variable. So we have to look in our problem and see if one of those amounts is based off of the other or referenced off of the other. And it is. Day shift produces 5 times as many as night shift. So which one is going to be X? The number for night shift or day shift? Night shift, because day shift is 5 times that, or 5X. And they add up to 1,780 units. So 5X plus X equals 1,780. What are we going to do from there? Well, 5X and X, we treat that as 1X combined to make 6X. And then divide by 6. X equals what? That ain't going to work real well, is it? Boy, it's late at night. Yeah, 298.67. Yep. Sorry about that. Little hamster's done for the night. You guys get the point. We might also have one that looks like this. If cards are $6 and folders are $2. In a day where 15 units are sold, for a total of $70. How many of each were sold? So we've got cards and folders. We're looking at the number sold. Now here, is one of them referenced or one of them based off of the other? Not really. It doesn't say that one is 3 times as many or twice as many or even a certain number more than the other. But it does give a reference for the 2 of them. There's a total given. 15 total units sold. So if we let one of them, we'll let the number of folders sold be X. The other number has to be the total minus that. So 15 minus X. However many folders I sold, I subtract that from the total of 15 to get the number of cards sold. But here I don't have the total number of units. I have a dollar amount. So I have to put in my dollars, which is $6 each for cards and $2 each for folders, and convert those numbers sold into dollar amounts. And I just do that by multiplying. So for the amount of so for the dollars from cards, it is 15 minus X times 6, or 6 times 15 minus X. For the dollar amount for folders, it's X times $2, or 2X. That is going to add up to $70. So 6 times 15 minus X plus 2X equals 70. So we go from there. Distributing the 6 times 15 is 90. 6 times negative X is negative 6X. Plus 2X and equals 70. Next, we have the negative 6X and the 2X combined to make negative 4X. So 90 minus 4X equals 70. From there, we're just solving the equation for X. We're subtracting 90. Negative 4X equals negative 20. and dividing by -4. X equals 5. Are we done? No. We're asked how many of each. X is the number of folders, so there's 5 folders. How many cards? 15 minus X, or 15 minus 5 would be 10 cards. Okay, only one more example I want to show you, then I'll turn you guys loose for the night. If simple interest is given by I equals PRT. We went over some examples of this last week. If $120 interest is charged on a, what do I want to do here? $8,000 loan for 1 month. Find the rate. So we have that formula, I equals P RT. I is our amount of interest. Do we know that? 120. Do we know the principal? That'll be the 8,000. Do we know the rate? Find the rate. So that's going to be R. We're just going to leave that in as a variable. Time is a little tricky. 1 month. Now, time is always given in years. So 1 month would be 1/12 of a year. So now to solve this, we have R over here that we're solving for. We have the 8,000 and the 1/12. We can combine 8,000 and 1/12 by multiplying them out, which is going to give us 666.666. Now this can cause some small problems. If we're really concerned about having exact answers, this can cause a round off error. For what we're going to do, we should be okay if we go just a few decimal places. So we're 666.667 times R. We're going to divide now by the 666.667 to get R by itself. So now what I'm going to do in my calculator is I'm going to do this. I'm going to do 120 divided by, and all of your calculators should have this function. Hit second or shift. You'll see down here this says ANS. That's telling my calculator to divide the 120 by the previous answer. So rather than typing back in my rounded off number of 666.667, the calculator is actually taking the exact result of that previous answer. That gives me 0.18. So if you answered that your rate is 0.18, I would accept that, or you can convert that to a percent of 18%. Pretty steep interest. Any questions? Any of the topics for our test for next week that you want to see more examples of, or you're not sure of, don't feel good about? Okay, well for next week, actually for tomorrow, there is a new quiz. It'll be on MyMathLab. It'll be due once again tomorrow night, Wednesday night at 11:59 p.m. And there will be a new homework due for next week. And then next week when you get to class, if you have questions, there will be plenty of time to answer questions once you get here. Otherwise, you can start in on the test as soon as you get here as well. You'll have the whole 3 hours to do the test. Hopefully you won't need it. And as I said, if you want to take the test earlier in the day, you are welcome to. The computer lab down the hall here in Rice Lake is open for you if you want to work on either the quiz or the homework. Otherwise, we will see you next week.